Okay, now we're going to look at some pulleys. So, pulleys are practically going to be the kind of same scenario as a lift, but you've got two of them going on at the same time. Now, let's just have a look at the information given to us here, and just to explain the scenario. So it says the diagram below shows two particles, just weights basically, A and B, of mass 2 kilograms and 5 kilograms respectively, which are connected by a light, inextensible string passing over a fixed, smooth pulley. So what's happened here basically is you have, I'll go for a bright green, this box A here is attached to a string, is passing over this smooth pulley, so we can just slip over that, you can slide over that, fine, and that's attached to B down there. So basically, because B is going to be a bit heavier than A, it's going to end up falling and pulling A around that pulley. It's going to end up pulling A up because they're attached by that string. We'll have a look at what the point of light, inextensible and smooth are in a bit, but to have a look at the forces at play now, very, very, very similar to lifts. A has a mass of 2 kilograms from the question, so that means it's got a weight of 2 gravities. B is 5 kilograms, so it's got a weight of 5 gravities. And again, stopping B from just free falling, even though it probably will fall, but at a slower rate, it'll accelerate with a smaller rate, is the fact that this rope is attached to something at the other end. So the rope is actually holding it up a bit. Also, the rope is going to pull this particle A up, because it's attached again on the other side to B. So there'll be a tension force in that rope pulling A up, and it'll be hindering B slightly too. So again, very, very similar to the lifts examples. It's just I've got two either side. Then if we have a think about our acceleration, then probably our acceleration is going to go down over this side, B is going to go down, and A is probably going to shoot up. It's going to accelerate upwards over there. And now all I've got is two scenarios for Newton's second law, and we can have a look then at what we need to do. So in this scenario, what should I pick? I'll have a nice purple. There we go. It asks us to calculate the magnitude of the acceleration and the tension. Okay, so the acceleration is going to be the same from A and B, again because that string is inextensible, it's not a stretchy string. So if B basically falls, then it's going to pull A with it at the same rate. So the acceleration is going to be the same, and the tension in the string. So all you have to do is have a look at Newton's second law on the one particle, and what does it mean? And then also have a look at Newton's second law on the other particle, and what does that give you? So again, think of positive direction. Well, A is going up, so I'll take that as positive. And B is going to be accelerating down, so I'll take that as positive. There we go. So Newton's second law on A, what does that say? Well, up is positive. So it says that the sum of all the forces is equal to the mass times the acceleration. And the force going up is the rope pulling it. Force acting down is its weight. And that should equal the mass times the acceleration. I'm going to call that number 1. That's an equation that'll be handy. I know what gravity is, remember I know what G is. I should know what the tension and the acceleration are. Newton's second law on B as well. That tells us that the sum of all of the forces equals mass times acceleration. And in this case, I've taken positive as down because it's going to be accelerating down. So it's the weight acting in the positive direction, and the tension is hindering it in this case. And that will equal its mass times the acceleration. I'll call that number 2. And now then, I basically have simultaneous equations to solve. And look, I've got a t and a minus t here, so if I add them together, 1 and 2, then that will give me t plus minus t cancel out. Minus 2g and 5g, that's 3g's. 2a and 5a is 7a. So hopefully now then A is equal to 3 gravities over 7. 3 times 9.8 divided by 7. I did work that out earlier, is 4.2 meters per second squared. That's the acceleration. Again, because that string isn't like an elastic band, if one of them's accelerating at the other at a rate, then the other one is being pulled because the string is inextensible. So they both go in with that rate. And then, so that's the acceleration. Oh yeah, if I sub that back into 1, then I get, therefore, tension is equal to 2 accelerations, 4.2, plus 2 gravities. All I've done is just rearrange that first one there. And 2 times 4.2, add 2 times 9.8, I think it's 28 newtons apparently. So the tension then there I get from just substituting the acceleration back into either of the equations. I just substituted it back into the first one. So that's basically what you're going to have to do with these pulleys. Have a look at what forces you have acting on each of the particles. Do Newton's second law on the one. Remember to pick a positive direction, preferably the direction of acceleration. And then do Newton's second law on the other. And you're going to have simultaneous equations to solve, usually fairly straightforward, like that. Now, they may ask you for a sneaky mark, what does this assumption mean? So again, the string being light. So if the string is light, that means that you can ignore its mass. So that's what I've said here down the bottom. So light means we don't have to consider its mass, so there won't be any extra weight added to these scenarios. Also, the other few things that they may ask you on, maybe the inextensible part. Well, inextensible means that it isn't stretchy. So if it was stretchy, then if B fell, it could start accelerating before it kind of pulls A, because the string could stretch for a little bit. So the acceleration could be inconsistent there, whereas these will always be inextensible strings. So the acceleration will always be the same because of that. They may ask you, what does inextensible mean, or what does it enable you to make? What assumption does it enable you to make? Also, the smooth pulley. Well, if the pulley was rough, then the string could snag on it, and maybe the tension there would basically be different, because you may have B trying to pull down, but it's getting kind of caught there, and it's not able to pull the rest of the string properly because it's getting snagged on there. So the tension would be different. So, but these will always be smooth in our cases, but they just may ask you, what assumption does smooth for the pulley help you make? And that's just that the tension throughout the rope is consistent. So they are the three important things. Light means you can ignore the weight. You can ignore its mass, so there's no extra weight or any extra forces to think of. Inextensible means that the acceleration is going to be consistent, and smooth means that the tension is going to be the same all the way through the system. There we go. Thank you very much. Ta-ta.